Hello, everybody. My name is Murat Cankurt. I am currently working in North Carolina A&T University. Today, I am here to present our pre-study on investigating the role of artificial intelligence in climate change mitigation through carbon farming. Particularly, this study is a preliminary study of our project supported by German government and private sector in Kazakhstan. Okay. I'm beginning with the question. It's very important question. It's a big question. What is the meaning of agriculture in human life? What do you think about that? I think it's very important. I say that this is the agriculture is a life of human life, I think. We depend on agriculture as long as we breathe. We depend. Imagine, imagine please, a world where technology and nature work hand in hand to fight climate change. A world where we don't just react to environmental damage, but proactively reverse it. That's the promise of AI in carbon farming. By using advanced AI tools, we have the power to transform how we manage our farm, turning them into powerful carbon sinks that capture and storage greenhouse gases while boosting crop yields and soil health. Today, we are not just talking about farming, we are talking about a groundbreaking approach to climate resilience. In this presentation, we will explore how AI is unlocking new opportunities in carbon farming, helping us create sustainable agriculture practices that could redefine our fighting against the climate change. Let's start into how this technology can be a game changer for both our planet and the future of farming and agriculture or human life also. Climate change is one of the biggest challenges facing the agricultural sector today. It's important to understand that agriculture plays a dual role here. It's not only a significant contributor to the global greenhouse gas emissions, but also the potential to be a powerful tool for reducing these emissions. There are two roles. In fact, agriculture accounts for about 24% global greenhouse gas emissions, mostly from methane produced by livestock and fertilized soil. These numbers highlighted the impact of conventional farming practices on our environment. However, there's a promising approach that's gaining traction known as carbon farming. So why agriculture is indeed a part of the problem, it's also a crucial part of the solution when we apply and we apply strategies like these that support both the environment and sustainable farming. Now, carbon and carbon farming. I'm continue quickly this one. We know carbon. Carbon is an element, very basic element, and carbon is common found in nature. We made of carbon. For example, my body is 16% carbon. Soil, microbes works with carbon. Everything is made of carbon. Carbon is present as additional, that carbon is present as carbon dioxide in the atmosphere and contributes to the greenhouse gas emissions also. However, there's a lot of confusion and many questions about the role carbon in the world. Carbon farming is a set of agricultural practices also. The main goal of carbon farming is to mitigate climate change by removing carbon from the atmosphere and storing it in the soil. Removing to atmosphere and storing in the soil. This is the carbon farming. It is sometimes called regenerative agriculture. Carbon farming is important to ensure the long-term sustainability of agriculture by increasing ecological sustainability. And there is the difference between conventional farming and regenerative farming. Conventional farming, conventional farming of sometimes we call the commercial agriculture is focused on the highest yield and intensive use of resources like fertilizers, pesticides, like that. This approach can lead to soil degradation and loss of biodiversity also. Regenerative agriculture is on the other hand, regenerative agriculture aims to restore soil healthy, increase biodiversity, and improve water cycle. AI can, what was the carbon farming techniques? One of them is no-till or reduced tillage techniques. No-till farming, the soil is not plowed. It's sometimes and somewhere not suitable. That's why we have the others. The others technique is a cover crop. Cover crop is these are plants that grow between main crops. Generally, cover crops flow to the farmer, but not good. Not good. The other one is organic fertilizer. If we use organic fertilizer, our soil structure is getting better. And what was the organic fertilizer? Fertilizer made from the organic material. The other one is biochar. Biochar is like that a char, a carbon-rich material produced by plant material in an oxygen limited environment, and and at high temperatures. Sometimes strategically, we decide to combine all these techniques together. What was the impacts of carbon farming? If we use the carbon farming, improve soil health and structure, enhance water retention capacity, increase biodiversity, and increased ecosystem health. Okay, now AI is transforming many sectors, and one of the most exciting opportunities is its application in carbon farming also. With AI tools like precision agriculture, automated data analysis, predictive modeling, farmers now have the power to make that data-driven decision in real time and simultaneously. Imagine being able to monitor soil healthy, track crop condition, even predict carbon capture level instantly, all thanks to AI. This isn't just about improving day-to-day farming practices, it's about scaling up carbon sequestration on a much larger, making it more efficient and accessible. As we dive deeper into this topic, we will explore how AI can help us advance carbon farming techniques and boost climate resilience in agriculture. We can monitor, AI can monitor also soil healthy by analyzing data from sensor and satellite imagery simultaneously and real time. When we can check some parameters like that, for example, soil adjusted vegetation index, normalized difference vegetation index, leaf area index of the plants by the satellite using the AI. AI models can predict soil organic matter levels or recommend us some options or some practice options also. Let's go to practice. For example, we are in Connecticut now. From Connecticut, we can monitor the condition of our crops and soil in our field in Kazakhstan. And additional that, if we use some additional system or devices, even take some actions, some soil irrigations like that. For example, in this slide, you can see this NDV scores, NDV index, where we come from the AI results also. NDV is normalized difference vegetation index. What does it mean of index? Index is numerical indicator that assesses the quality and quantity of vegetation. It's calculated using data from satellite imagery and provides information about the healthy status of each plant, like a 1 square feet. NDV is calculated based on intensity of reflect light in the red and near infrared light bands. Healthy plants absorb LED lights. Healthy plants absorb LED lights, red lights, and reflect near infrared lights. That's why we understand that some plants is healthy, some plants are not healthy. Due to this feature, and the VI shows high values for healthy plants or low values for unhealthy plants and stressed plants also. I'm going fast over there. Also, AI-driven system can optimize water usage, fertilization, and crop management. For example, AI-based irrigation system in Gujarat reduced water use by 30%. Also, topology, we can monitor the topology and we use the irrigation of these. Also, AI model predict the carbon sequestration potential of various practices over there in the literature is very good results. AI model supports the large scale project by optimizing carbon farming strategies. I'm going on fast. When we look at the future direction and policy recommendations, but one of them is AI carbon farming shows promise, but there are key challenges. High cost may make AI techs hard to access for small farmers, especially in developing country. Lack of technical technical skills in another issue, so we need better training programs. Data quality is also a problem, additional problem. Many areas don't have reliable agricultural data, particularly undeveloped country or developing country also. Plus, it's a big issue that AI itself can have a big carbon footprint. So we must focus on the energy efficiency solutions. I think promote policy frameworks and international collaboration for AI carbon farming. AI-driven carbon in the combination, AI-driven carbon farming offers a great way to tackle climate change while boosting sustainable agriculture. With AI, farmers can use resources more efficiently, increase carbon capture, and grow healthier crops. But to make this a reality, we need to solve issues like high cost problem and limited access problem, and the need for technical skills for particularly farmers' technical skills. That's where support from governments, research groups, and business is crucial. AI doesn't just improve farming. It's also promotes social and environment benefits by helping farmers make smarter decisions. Moving forward, we need more investment in research, policies, and training to unlock AI full potential in fighting climate change. Our goal is make AI a key driven of sustainable, climate resilient farming that benefit everyone. Thank you for your interest.